So my name is Peter Taylor, and I'm the Director of the Victorian Life Sciences Computation Initiative. So there's little doubt at the moment that there is a new biology. That's a global phenomenon. You can see countries getting into, for example, sequencing, genome sequencing, understanding organisms, even synthetic biology, creating new organisms. And these are things that we'll see far more of, but they're very expensive technologies very often. The advantage of computing as a technology to be incorporated as part of this is that, relatively speaking, computing is very cheap. This is something that's been taken advantage of in engineering and the physical sciences for a long time, and those disciplines are relatively mature in their use of computers at all scales. The life sciences have come along later, and one of the differences between running, say, a computer center dealing with all fields of science and what we're trying to do at VLSCI, which is focus exclusively on the life sciences, is we put a significant effort into developing the users, developing a relationship with the users to try to accelerate the penetration of computing in the field of the life sciences. The Victorian Life Sciences Computation Initiative was set up several years ago through an initiative by the state government, who provided $50 million in cash. The University of Melbourne also contributed cash, so it's a partnership between the state government and the University of Melbourne. And then it also involves Monash University and La Trobe University. We have people involved from those places, and over the first 5 years we expect the total budget to be some $100 million. Among the activities we've had here recently include people who for the first time have been able to sequence an entire genome for a parasite, which they can now use to investigate ways to handle that parasite. It's an infection in sheep and causes huge problems there. In the field of human medicine, we have somebody who was able for the first time to simulate the assembly of an entire polio virus from the individual molecular components. And once you can understand how to do that, you can start to figure out how to interfere with how those viruses are constructed. So these are two examples where computation has been used to address particular relevant life sciences problems. Melbourne is the life sciences capital of the Asia-Pacific region. We have around the Melbourne area by far the greatest concentration of life sciences researchers and indeed recipients of life sciences research funding in Australia. At the same time, we have the expertise in the information and communications technology, in the networking, in the data handling and the numeric processing that are all needed to bring these things together. Part of it is historical. I think Melbourne is like this because it's grown up with this concentration of hospitals around the university, great strength in the life sciences, institutions like Peter Mac and WeHi and so forth. And these institutions go back a long way. But in addition to that, I think there's been investment in Melbourne, both by the university in building up these activities and by the state government, which provides us with a large part of our funding here at VLSCI. And that also, I think, contributes greatly to the successes here.